Tonight, we're going to dismantle an image that's been sitting quietly in your mind since childhood. The image of a pristine silver moon, untouched, ancient, hanging in the black sky above your bedroom window, exactly as it has hung for 4.5 billion years, indifferent to us, unreachable, undisturbed. You've seen it 1,000 times. In picture books, in old photographs, in the soft glow through your curtains on a summer night. A perfect cratered face, silent, distant, ours only to look at. But that image is no longer true. Somewhere on the far side of the moon, in a place no human eye has ever directly seen from the ground, there is a fresh scar. 2 of them actually. Side by side, overlapping, punched into the ancient regolith by something that came from us. Something we built, launched into the sky with fire and thunder, and then forgot about. Something that drifted, silent and tumbling, through the empty corridor between Earth and the moon for 7 long years. And then, one quiet morning in March of 2022, at roughly 25 minutes past noon Greenwich Mean Time, it arrived. 4 tons of cold metal, striking the lunar surface at nearly 9,300 kilometers per hour. Faster than any bullet, faster than any sound, faster than anything you have ever seen move in your life. And nobody was watching. Nobody saw the flash. Nobody heard the impact, because in the vacuum of space, there is nothing to carry sound. The moon simply absorbed the blow, the way it has absorbed billions of blows before, and rolled on through its slow, patient orbit as if nothing had happened. But something had happened. Something quiet and strange, and, if you sit with it long enough, deeply unsettling. Because here is the question that will follow us through this entire night. The question that might, if you let it, keep you awake a little longer than you planned. What if the things we launch into the sky are not really going away? What if every rocket, every booster, every discarded upper stage that we cheer into orbit and then stop thinking about is not gone at all, but only delayed, drifting, waiting, circling in patient, invisible loops until one day, without warning, it finds its way home? Or worse, finds its way somewhere else entirely, and leaves a mark that will still be there 100 million years from now, long after every trace of you and me and every person who has ever lived has been erased from this planet. Tonight, we are going to tell the full story of that impact. The story of a rocket that was supposed to help us watch the sun, and instead ended up crashing into the moon. A rocket that most of the world believed was a SpaceX Falcon 9, launched by an American billionaire in 2015 to carry a satellite toward a distant balance point in space. A rocket that was tracked, argued over, misidentified, re-identified, denied, and finally, quietly, allowed to hit. And when the dust settled, when a small robotic spacecraft in lunar orbit finally photographed the crash site, the astronomers looking at the images realized something was very wrong. The impact had not left one crater. It had left 2. 2 clean, overlapping wounds in the lunar soil, as if whatever hit the moon had been carrying something heavy on both ends. Something we were not told about, something we may never fully identify. This is a story about a machine that outlived its mission. It is a story about how easy it is to lose track of the things we send into the sky. It is a story about the growing, invisible cloud of debris that now surrounds our planet and stretches thinly all the way to the moon. And in the end, it is a story about what it means to be a species that has finally learned how to leave permanent marks on worlds we have never even set foot on. We will go slowly. We will trace the whole arc. From the fire of the launch pad in Florida to the tumbling 7-year drift to the moment, a single retired programmer at a desk in the state of Maine noticed a smudge of pixels on his screen and realized with quiet astonishment that it was on a collision course with the moon. We will follow the mistaken identity, the international denials, the crash itself, and the strange double crater that no one can quite explain. And by the end, we will zoom out far enough to see that this single event, this one small dent in the lunar surface, is only the very first drop of something much, much larger gathering above our heads. Before we go any further, if this is the kind of slow, deep exploration you enjoy, the kind of story you can lie back and listen to without being shouted at, a quiet like or subscribe genuinely helps this channel keep going. It is a small thing for you, but it makes an enormous difference on my end. Thank you. Now let us begin properly. So here is my first question for you, and I would love to read your answer in the comments. When you were a child, before you knew anything about rockets or orbits or space debris, what did the moon feel like to you? Was it a friend, watching you from the window? Was it a distant, cold thing you never really thought about? Or was it something in between, a quiet presence you took for granted, the way you take gravity for granted, until one night you finally looked up and really, truly saw it? Tell me. I want to know what the moon meant to you before you knew it could be hit. Let us begin with the picture in your head, the one you have carried without ever really examining it since you were small. A rocket sits on a launch pad. It is white, or nearly white, tall as a building, wrapped in wisps of vapor that curl down its sides in the cool morning air. A voice counts backward from 10. At 0, a column of fire erupts beneath it, brilliant and impossibly loud, and the machine lifts, slowly at first, then faster, then impossibly fast, arcing up through the blue sky and vanishing into the black above. Somewhere in a control room people cheer. Somewhere a satellite deploys. The mission is a success. The rocket has done its job, and the story in your mind ends there. That is the familiar image. It is tidy. It is complete. It is comfortable. And it is, in almost every meaningful way, a lie. Because rockets do not simply disappear when they reach the sky. They do not evaporate. They do not politely fold themselves up and vanish once the payload is delivered. What actually happens is stranger and messier, and far more haunting than the picture we grew up with. A rocket, when you strip it down to its most basic function, is a very tall metal tube full of fuel, with an engine at the bottom and something valuable at the top. To reach space, that tube has to shed its own weight as it climbs. So it is built in stages, sections that fire, burn through their fuel and then detach, falling away into the sky behind the rest of the rocket, so that the remaining, lighter machine can push on toward its destination. It is a kind of controlled unraveling. a slow, deliberate discarding of pieces of itself, all the way up. Most of those pieces come back down. The first stage, the biggest and heaviest, usually falls into the ocean, or, in the case of modern SpaceX rockets, lands itself gracefully on a floating platform to be flown again. That part of the story, at least, has become familiar to us. We have all seen the footage. The tall booster descending on a pillar of flame, touching down on a barge somewhere in the Atlantic like a slow, gentle miracle. But the upper stage is different. The upper stage is the part of the rocket that pushes the payload the rest of the way, out beyond the thick air of the lower atmosphere, all the way to orbital speed, or, in some cases, all the way to another destination in space entirely. And because the upper stage has to go so high and so fast, it very often ends up somewhere it cannot easily come home from. Sometimes it is deliberately steered back into the atmosphere to burn up. Sometimes it is pushed out into a graveyard orbit, far from anything important, where it will drift for centuries. And sometimes, when the mission is unusual enough, when the destination is far enough, when the fuel is thin enough, the upper stage is simply left. Released into whatever trajectory it happens to be on at the moment its job ends, with no plan for what it does next. Left to drift. Let that phrase sit for a moment. Left to drift. Because that is the phrase at the heart of tonight's story. That is the quiet fact that no one at a launch celebration ever mentions. That is the small, easily overlooked detail that grows, over the years and decades, into something much larger than any single mission. Every time a rocket goes to a very distant place, to the moon, to a Lagrange point, to a deep space observatory, there is a very real chance that some piece of it, some spent, exhausted metal shell weighing several tons, is quietly abandoned along the way. Left to whatever orbit physics happens to give it, left to circle the Earth, or the Sun, or the Moon, on a path that no human being is actively watching, left in effect to become part of the sky itself. And that is where our story truly begins. Not on the launch pad, but in the moment after the cheering stops. On the 11th of February in the year 2015, on a cool evening at Cape Canaveral in Florida, a Falcon 9 rocket, built by a private American company called SpaceX, rose from its pad into the dusk. The launch was, at the time, a fairly quiet one, at least by the standards of what SpaceX would later become. There was no attempt to land the first stage on a platform that day. The weather was too rough at sea. So the booster performed its job and then simply fell into the ocean, unrecovered, as boosters had done for decades before. But the payload the rocket was carrying was quietly extraordinary. It was called DSCOVR, the Deep Space Climate Observatory. A satellite so small it could almost fit in the back of a large car, but destined for a place so distant, so strange, that no consumer camera has ever really captured the scale of it. DSCOVR was not going into orbit around the Earth in the usual sense. It was being sent to a place called the L1 Lagrange point. And to understand what that means, you have to picture something that is a little difficult to picture. Imagine a straight line drawn from the center of the Earth to the center of the sun. Now, somewhere along that line, at a distance of about 1.5 million kilometers from Earth, roughly 4 times farther than the Moon, there is a very special point. A point where the gravity of the sun pulling outward and the gravity of the Earth pulling inward balance almost perfectly, in such a way that a small object placed there can stay put, hovering in the sunlight, always positioned between our world and our star. That is L1. That is where DSCOVR was going, to sit, essentially forever at the balance point, watching the sun for solar storms and keeping a permanent eye on the sunlit face of Earth. It is a beautiful mission, a satellite hanging in the light between two great gravities, watching everything at once. But to get a satellite to that place, you need a rocket that can push it a very, very long way. And once you have pushed it that far, once you have delivered the payload to its distant balance point, there is a problem. The upper stage of the rocket that carried it there is now also a very long way from home, too far to come back, too tangled up in the gravity of the Earth, the Sun, and as it turned out, the Moon, to safely fly anywhere in particular. And it did not have enough fuel to do anything about it. You see, a mission like DSCOVR uses almost every drop of propellant it has to reach its destination. The Falcon 9 upper stage that delivered the satellite was, by the time its job was finished, essentially empty. A hollow metal shell, roughly 14 meters long, weighing around 4 tons, coasting through space on the last little push it had left in it. Under normal circumstances, mission planners would use whatever fuel remained to steer that upper stage into a safe, controlled trajectory. Either back down into Earth's atmosphere, where it would harmlessly burn up, or out into a distant orbit around the sun, where it would drift, unbothered for millions of years, far from anywhere it could cause trouble. Both options require fuel. And by the time DSCOVR was on its way, there was not enough fuel left for either. So the upper stage of that Falcon 9 was simply released, set free, left to drift. It began its long, slow tumble through the empty space between Earth and the Moon in a chaotic, looping orbit that no one at the time particularly cared about. It was, after all, just an empty tank, a piece of used hardware. In the celebration around DSCOVR's successful launch, in the headlines and press releases and mission briefings, the fate of that spent upper stage was, at best, a footnote. At worst, it was not mentioned at all. The rocket had done its job. The satellite was on its way. The mission, as far as the public was concerned, was over, but the physics did not stop. The tumbling continued. The empty stage, 7 stories of hollow metal, kept moving through space, pulled this way by the Earth, that way by the Moon, occasionally nudged by the pressure of sunlight itself. It looped and drifted and slowly, over the course of years, followed a path that no one on the ground was watching closely. It did not decay back into the atmosphere. It did not fall into the sun. It did not fly away into the darkness never to be seen again. It simply hung in the space between worlds, one of a growing population of forgotten machines, quietly rehearsing an ending that no one had yet imagined. And that is the crack in the familiar picture. That is where the tidy image begins to fall apart. Because if you were paying attention, if you had the right software and the right patience, you could have followed that piece of rocket for the entire 7 years it drifted. You could have watched its long, looping ellipses stretch and shift and slowly, almost imperceptibly, curve toward something none of us had anticipated. Something round and gray and heavily cratered. Something you have looked at your whole life without ever thinking, even once, that a piece of a SpaceX rocket might one day find its way into it. And we haven't even reached the part where somebody notices. We haven't reached the part where a single retired programmer, sitting at his desk in a quiet town on the coast of Maine, opens a piece of tracking software one January morning in 2022 and realizes that a smudge of light he has been watching for years is now on a direct course for the surface of the moon. That is where things begin to accelerate. That is where the quiet drift becomes a countdown. But before we go there, let me ask you this, and I would genuinely love to know your answer. When you watched a rocket launch on television, or on your phone, or maybe, if you were very lucky, with your own eyes from somewhere along a coastline, what did you think happened to it once it left the screen? Did you assume, the way most of us do, that it simply went up there, to some vague, tidy place where things belong once they leave the ground? Or did you ever, even for a moment, wonder where all of it actually ends up? The tanks, the stages, the bolts, the panels. Tell me in the comments. I want to know when, in your life, you first realized that space is not empty, that the sky above us is, in fact, quietly filling up, because that realization is exactly where we are going next. To the moment when one man at one desk looks at his screen and sees, for the very first time, that something is coming home. To understand how the world found out about the coming impact, you have to understand a man most people have never heard of. A man whose name does not appear on any spacecraft, in any mission patch, or in the credits of any documentary you have ever watched. A man who works from a modest home on the coast of Maine, in the far northeastern corner of the United States, in a small town where the winters are long, the nights are dark, and the sky, when the clouds break, is spectacularly full of stars. His name is Bill Gray, and for decades, quietly, patiently, almost invisibly, he has been one of the most important trackers of small objects in the solar system that you have never heard of. Bill Gray is not a NASA astronomer. He is not affiliated with a great university. He does not command a telescope on a mountaintop or write papers that make the front pages of science journals. He is, by his own description, a retired programmer, a man who once wrote software for other people and now writes it largely for himself. His software has a strange, quiet name, Project Pluto, and its purpose is to do something that sounds simple but is, in practice, extraordinarily difficult. It takes the raw observations of small, dim, moving objects, asteroids, comets, pieces of forgotten spacecraft, and it works out where those objects have been, where they are now, and most importantly, where they are going. For decades, professional astronomers and amateur observers around the world have used Gray's tools to keep track of the fast-moving, faint smudges of light that flicker across telescope images. rocks the size of houses, icy visitors from the outer solar system, and increasingly the growing population of human-made debris that drifts through cislunar space, the vast, mostly empty region between the Earth and the Moon. Because most of the world's attention is fixed on the objects in low Earth orbit, the satellites and the space stations, and the visible clutter just above our heads, very few people are watching what happens further out. Very few people are watching the quiet corridor where forgotten upper stages tumble in long, looping paths that can take weeks or months to trace. Bill Gray is one of the very few who does. And on a January evening in 2022, sitting at his desk in Maine, he saw something that made him lean closer to his screen. There was an object he had been tracking for years. He had first spotted it in March of 2015, only weeks after DSCOVR was launched, when a telescope in Arizona, part of an asteroid survey called the Catalina Sky Survey, picked up a faint, moving speck of light drifting across the darkness beyond Earth. At first, that speck was catalogued the way any unknown object is catalogued. It was given a temporary designation, WE913A, a name that sounds like a license plate, because in a way, that is exactly what it is. A placeholder until someone figures out what the object actually is. Bill Gray, working alone at his desk, ran the calculations. The trajectory of WE913A did not match any known asteroid. It did not match any known comet, but it did match, almost perfectly, the departure path of a very specific object. The upper stage of the SpaceX Falcon 9 rocket that had launched DSCOVR only weeks earlier. The math was clean. The timing was exact. The orbit fit. And so, quietly, without fanfare, WE913A was reclassified in Gray's own catalog as what he believed it to be. Not an asteroid. Not a comet. A piece of a rocket. A ghost of the 2015 launch, still drifting, still tumbling, still very much out there. For 7 years, that ghost went about its business. It looped, it drifted, it made long, slow passes near the Earth and the Moon. Its orbit was chaotic, in the technical sense. Small nudges from the gravity of the Sun and the pressure of sunlight and the slight uneven pull of the Earth and Moon meant that its exact path, months or years in the future, was fundamentally unpredictable. You could not say, with any confidence in 2016 or 2018 or even early 2021, where WE913A would be 5 years from any given moment. All you could do was keep watching, keep updating the orbit, keep refining the numbers as fresh observations came in. And then, in early January of 2022, the numbers changed. Gray was doing what he did every day, running new observations, updating his catalog, checking the predicted paths of the objects he had been tracking. And when he ran WE913A through his software with the newest data, something on his screen stopped him. The projected path of that 7-year-old piece of rocket, that quiet, tumbling ghost of the DSCOVR launch, no longer curved harmlessly around the Earth-Moon system. It curved unmistakably into the Moon itself. The predicted impact date was less than 7 weeks away. The predicted impact location was on the far side. The predicted impact speed was somewhere around 2.5 kilometers per second, roughly 9,000 kilometers per hour, fast enough to punch a fresh crater into a surface that had been undisturbed by anything but random rocks for millions of years. Let that number sit for a moment. 9,000 kilometers per hour. If you were standing on a highway and a car passed you at 100 kilometers per hour, that would feel fast. If a bullet from a high-powered rifle passed you, it would be moving at somewhere around 3,000 or 4,000 kilometers per hour. This piece of rocket, this abandoned metal shell, was going to hit the moon at more than twice that speed. And it was going to do it in a matter of weeks, and nobody until that moment at a desk in Maine had noticed. Gray did what a good scientist does. He did not shout. He did not call the press. He posted the finding on his own small website. A quiet note, written in the calm, technical language of a man who has spent a lifetime looking at orbital elements and finds the math more interesting than the drama. A piece of a Falcon 9 upper stage, he wrote, appeared to be on course to strike the far side of the moon on the 4th of March, 2022. He posted the numbers. He posted his reasoning. He invited anyone with better data to check his work. And then, presumably, he went about his evening. The story did not stay quiet for long. Within hours, the note was picked up by other astronomers and by science journalists who had been quietly following Gray's work for years. Within a day, it was in mainstream headlines around the world. A SpaceX rocket, the headline said, was going to crash into the moon. A piece of Elon Musk's American rocket company was, for the very first time in history, about to leave a fresh, human-made scar on the lunar surface. And it was going to do it in less than 2 months. The reaction, at first, was a strange mixture of fascination and mild outrage. Some people were delighted, in a slightly morbid way, at the poetry of it. A private company, one that had done more than any other in the 21st century to reopen humanity's road to space, was about to accidentally become the first entity in human history to unintentionally strike the moon with a piece of hardware. Others were less amused. There were op-eds about space debris, about corporate carelessness, about the growing lack of regulation over what happens to the upper stages of commercial rockets. There were calls for SpaceX to explain itself. Some observers began looking at their calendars, marking down the 4th of March, wondering if the impact might somehow be visible from Earth. It would not be. The impact site, as Gray's calculations showed, was on the far side of the moon, the side that permanently faces away from us. The side that no one on Earth has ever seen directly with their own eyes, because the moon is what astronomers call tidally locked. It rotates on its axis in exactly the same amount of time it takes to orbit the Earth, roughly 27 days, and the result of that coincidence is that we on the ground always see the same face, the near side, the familiar face, the one with the seas and the great pale plains, and the pattern of dark spots that generations of humans have looked at and imagined as a face, a rabbit, a woman carrying firewood, depending on where in the world they lived. The far side, by contrast, is invisible to us. We only started seeing it at all in 1959, when a Soviet spacecraft called Luna 3 flew past and sent back the first grainy photographs. Since then, only a handful of spacecraft have ever seen it up close. And now, one of them was about to hit it. There was, of course, a slight problem with the story as it was being reported. A very quiet, very technical problem that would surface only a few weeks later. But in those first days of January and February 2022, no one was thinking about it yet. In those first days, the story was simple. A SpaceX rocket, a 7-year drift, a collision course, a countdown of about 7 weeks. A fresh crater about to appear on the far side of the moon, in a place that no one on Earth could see, at a time when no one on Earth could look. It was, in every sense, a slow-motion accident happening in absolute silence, 500,000 kilometers away. And it was, by the standards of anything humans had ever done in space before, unprecedented. Rockets had struck the moon on purpose before, of course, deliberately as part of scientific missions. The Soviet Union's Luna 2 became the very first human-made object to reach the moon in 1959, when it was intentionally crashed onto the surface as a demonstration of capability. NASA has spent upper stages into the moon on purpose since, most notably during the LCROSS mission in 2009, when a rocket was deliberately steered into a shadowed polar crater in the hope of kicking up water ice. But those were planned. Those were monitored. Those had teams of scientists waiting to watch the plume, to measure the flash, to gather the data. This one was different. This one was an accident, or, more precisely, a consequence. The consequence of a decision made 7 years earlier to leave a piece of hardware to drift. And here is the strangest part. As the January headlines gave way to February, and as the world's amateur astronomers began preparing to watch the moon on the 4th of March, hoping perhaps to see some faint disturbance in the reflected light of the lunar surface, Bill Gray was still at his desk in Maine, still checking his numbers, still refining the orbit, still doing what he had always done. And something in the back of his mind was beginning to bother him. The trajectory fit the DSCOVR launch. It fit it well. But something about the object's behavior, something in the pattern of its long, looping drift over the past 7 years, did not sit quite right. He had been sure, when he first identified it in 2015, that this was the Falcon 9 upper stage. He had been sure enough to enter that identification into his own catalog, and to leave it there, unquestioned, for 7 years. But now, with the whole world watching, with headlines everywhere calling it the SpaceX moon crash, with journalists writing about corporate space debris and about Elon Musk and about the future of lunar accidents, Bill Gray, quietly, was starting to wonder if he had made a mistake. He was about to check, and what he was about to discover was going to overturn the entire story. But before we go there, before we follow him back into his software and watch him retrace the 7-year history of an object he thought he knew, let me pause and ask you something. Because this is a story about noticing. About one man at one desk, quietly watching the sky while the rest of the world looks away. Have you ever been the only person to notice something that turned out to matter? A small detail at work that no one else caught. A change in someone you love that no one else saw. A pattern that only became clear because you had been paying attention when nobody else was. Tell me in the comments. Because there is something about Bill Gray, sitting alone in Maine with his tracking software, that speaks to a very old and very human role. The watcher on the edge of the village. The one who sees the thing coming before anyone else does. And I have a feeling many of you know that role better than you might realize. Now, let us follow him back into the numbers. Because in the story we are about to tell, the object on its way to the moon is not what everyone thought it was. And the truth, when it arrives, is going to be stranger than the headlines. The doubt began, as most important doubts do, with a stranger sending an email. Some weeks after Bill Gray posted his prediction, and after the headlines of the world had already settled on the story of a SpaceX rocket crashing into the moon, a message arrived in his inbox from a man named John Giorgini. Giorgini works at NASA's Jet Propulsion Laboratory in California, at a place called the Solar System Dynamics Group, and his job, in essence, is to track the positions of things in space with a level of precision that most of us cannot really imagine. He runs a system called Horizons, which is one of the most authoritative sources in the world for the trajectories of natural objects and known spacecraft. And John Giorgini, having read Bill Gray's note about the impending impact, had done what a careful scientist does. He had checked. His email, as Gray later described it, was polite, understated, almost apologetic in tone. It said, in effect, that Giorgini had looked at the trajectory of the DSCOVR upper stage, based on NASA's own tracking data from immediately after the 2015 launch, and it did not appear to go anywhere near the moon in early 2022. In fact, the DSCOVR upper stage, as far as JPL could tell, had passed by the moon at a considerable distance shortly after launch and then wandered off into a heliocentric orbit, an orbit around the sun, where it had almost certainly remained ever since. The path did not fit. The numbers, when checked against the original mission data, did not match Gray's mystery object, which meant, quite simply, that WE913A, the tumbling piece of debris now less than 3 weeks from striking the moon, could not be the SpaceX rocket everyone thought it was. Imagine for a moment being Bill Gray at that instant. Imagine the quiet room in Maine. Imagine the software open on the screen, the 7 years of tracking data laid out in orderly columns, the confident identification you have been carrying since 2015 suddenly, quietly, coming apart in front of you. Imagine the world outside your window still going about its business. And 500,000 kilometers above your head, an object made by human hands still on its slow, patient path toward the lunar far side, indifferent to the fact that no one on Earth now knows what it actually is. Gray did what he had done his whole career. He went back to the numbers. He reopened his archive of observations, the one stretching back to that first sighting in March 2015, and he began, patiently, to reverse engineer the object's path. If it was not the DSCOVR upper stage, then what was it? He worked backward through the orbit, month by month, year by year, following the great looping ellipses back through 2020 and 2018 and 2016, all the way back into 2015, and this time further, into 2014. And there, in the autumn of 2014, the numbers pointed to something Gray had not expected, something that, in retrospect, had been sitting in the historical record all along. They pointed to a launch that had happened in China. On the 23rd of October, 2014, a Chinese rocket called a Long March 3C had lifted off from a launch complex in the mountains of Sichuan province, in the southwest of the country. It was carrying a small spacecraft called Chang'e 5T1. The mission was a rehearsal, a test run for a much more ambitious future flight, a mission that would eventually send a probe to the moon, collect samples of the lunar surface, and bring them back to Earth. Chang'e 5T1 itself did not land. It was designed to loop around the moon, swing back toward Earth, and test the tricky, high-speed re-entry that a real sample return would eventually require. The little test capsule performed beautifully. It looped the moon, came home, and parachuted down onto the grasslands of Inner Mongolia in a small, quiet triumph for the Chinese space program. But its rocket, of course, did not come home. The upper stage of the Long March 3C, the section that had pushed Chang'e 5T1 out toward lunar space, was left behind. Left, as we have said before, to drift. And Gray's reanalysis, when he ran the numbers, told him something remarkable. The trajectory of WE913A, the object he had been tracking for 7 years, matched the departure path of that Chinese Long March 3C upper stage almost perfectly. The dates lined up. The velocities lined up. The orbital shape lined up. The object that was now weeks away from striking the far side of the moon was, in all probability, not American at all. It was Chinese. And it was not 7 years old, at least not by the count Gray had been keeping. It was, at the time of impact, going to be roughly 7 years and 4 months into its long drift. Gray, to his enormous credit, did not hide. He did not quietly delete his earlier note and hope no one had noticed. He publicly corrected himself. He wrote a new post, explaining in careful, measured language what he had found. He described the email from JPL. He described the reanalysis. He wrote, with the honesty of someone who had spent a lifetime being wrong occasionally, and had learned to treat the experience as part of the work, that his earlier identification had been mistaken. The object heading for the moon was, in his best current assessment, the upper stage of the Chinese Chang'e 5T1 mission from 2014, not the SpaceX Falcon 9 from 2015. And he apologized. He said plainly that he was sorry for the confusion. The world's response was fascinating. Some journalists updated their stories quickly and quietly. Others corrected only in small notes at the bottom of otherwise unchanged articles. A great many did not correct at all. And even today, if you search for this event, you will find headlines from that period that still describe it as the SpaceX moon crash, as though the retraction had never happened. The image of an American rocket, a private spaceflight company, an eccentric billionaire, was simply too clean, too clickable, too story-shaped to let go of easily. Reality, as it so often does, had turned out to be more complicated than the headline. And China, when asked, did not accept the new story either. At a routine press briefing in Beijing, a spokesperson for the Chinese Ministry of Foreign Affairs was asked by a journalist whether the country acknowledged that a piece of its 2014 rocket was about to strike the moon. The reply was polite and firm. According to the spokesperson, the Chang'e 5T1 upper stage had re-entered Earth's atmosphere years earlier and burned up harmlessly. There was, from China's point of view, no rocket stage of theirs still drifting through cislunar space. The object heading for the moon, whatever it was not their responsibility. This is the point where the story becomes genuinely strange, because Bill Gray and every independent orbital analyst who checked his work remained confident in the re-identification. The trajectory really did fit the Chang'e 5T1 launch. The dates really did line up. There was no other candidate that fit as well. And yet the country that had launched that rocket was, publicly, denying that the object existed. Now, it is worth being fair here. It is entirely possible that the Chinese denial was based on a misunderstanding. The Chang'e program is complicated. There were multiple missions, multiple upper stages, multiple pieces of hardware in flight around that period. It is possible that a Chinese official, checking internal records quickly, saw that a stage from a different mission had indeed re-entered and burned up, and conflated the two. It is also possible, of course, that the denial was more deliberate. In the middle of an already tense period of international space competition, no country wanted to be the first in history to be officially credited with accidentally hitting the moon. Whatever the reason, the result was that, as the 4th of March 2022 approached, the world was facing a strange situation. An object, roughly the size of a bus, made of metal, weighing several tons, was going to strike the moon at nearly 9,300 kilometers per hour. Almost every independent expert believed it was a piece of a Chinese rocket. The Chinese government said it was not. The American government, meanwhile, made only quiet statements. The United States Space Command noted correctly that its own catalogs did not track objects that far from Earth in fine detail. Everyone, in effect, could disclaim responsibility because no one had been keeping close watch. And this is the crack in the picture that we have to look at properly, because the story of this impact is not really the story of one rocket. It is the story of a system, a way of doing space that we have been quietly practicing for more than 60 years, in which the afterlives of our upper stages have simply not been anyone's job. When a rocket delivers a payload to low Earth orbit, agencies are reasonably careful about what happens next. There are regulations about disposal orbits. There are guidelines about deorbiting. There are procedures, often flawed but at least existing, for tracking the debris. But when a rocket goes to a distant place, when it goes to a Lagrange point or on a lunar trajectory or out into interplanetary space, all of that fades. There is no international body responsible for tracking upper stages between Earth and the Moon. There is no rule that requires a launch provider to know where its abandoned hardware will be in 5 years or 10. The space between the Earth and the Moon, the vast, mostly empty corridor of cislunar space, has been treated essentially as a place where you can leave things and forget about them. And things have been leaving for decades. By the time WE 913A was on its final approach, the community of astronomers who pay attention to such things could name, off the top of their heads, several other pieces of forgotten rocket hardware known or suspected to be drifting through the Earth-Moon system. There is a Saturn V third stage from the Apollo era that spent decades looping through space and was, at one point in 2002, briefly mistaken for an asteroid and given a temporary designation before observers realized it was almost certainly the SIVB stage from Apollo 12. It is out there in some slow orbit around the Sun, and it may one day drift back into the Earth-Moon neighborhood. There is another suspected candidate that briefly became a temporary satellite of the Earth in the year 2020 before drifting off again, thought by many to be the upper stage of a 1966 Surveyor mission booster. There are others whose identities are lost entirely, catalogued only as unknown objects following unusual orbits, presumed to be human-made because their behavior does not fit any known natural body. The point is this: the Chang'e 5T1 upper stage, or whatever WE 913A actually was not a solitary ghost. It was one member of a small, quiet, growing population of forgotten machines circling in the space between our world and our moon. Some of them tumble in wide loops around the Earth. Some of them coast in slow orbits around the Sun. A few of them, occasionally, drift back into the Earth's neighborhood for a while before wandering off again. And every one of them, whether we admit it or not, represents a decision made years or decades earlier by some team of engineers on some mission somewhere, to leave a piece of hardware in place rather than dispose of it. The sky above us is, quite literally, a graveyard of forgotten last stages, and that graveyard is not sealed off from the moon. On the 4th of March 2022, one of its residents was about to prove that emphatically. There is something else worth sitting with here before we move on, something about the nature of the object itself. The upper stage of a Long March 3C, if that is indeed what it was, is not a small thing. It is roughly 12 meters long. It weighs, when empty of fuel, somewhere around 4 tons. It is made of metal, aluminum alloys, mostly, with tanks that once held liquid oxygen and kerosene, and engines at one end that were used to give the payload its final push toward the moon. Once released, it would have been tumbling, slowly, gently, but persistently, turning over and over in the vacuum, catching sunlight on one side and then falling into shadow on the other, warming and cooling in an endless cycle for years. Radar observations from Earth confirmed the tumbling. In fact, that tumbling is part of how astronomers were able to say, with growing confidence, that this was almost certainly a spent rocket stage and not, say, a large asteroid. Asteroids tumble too, but their light curves, the pattern of brightening and dimming as they rotate, look different. The pattern of WE 913A had the fingerprint of a hollow, elongated metal cylinder, rolling end over end through the darkness. And it was rolling, faster and faster in the language of celestial mechanics, toward a specific point on the far side of the moon. By late February 2022, the astronomers who had been refining the impact prediction had narrowed it to remarkable precision. The strike was going to occur on the 4th of March, at approximately 12:25 in the afternoon Greenwich Mean Time. The location was going to be inside a crater called Hertzsprung, an enormous, ancient impact basin on the far side, one of the largest craters on the entire lunar surface. Hertzsprung is nearly 600 kilometers across. It is not a fresh crater. It is a deeply weathered scar, roughly 4 billion years old, filled with smaller craters and worn ridges and the soft, undulating landscape of very old lunar terrain. Into this vast, silent bowl at 9,300 kilometers per hour, 4 tons of tumbling metal were about to arrive. Nobody would see it happen. The impact site was going to be in lunar night at the time of the crash, early morning by the moon's own slow rotation, still deep in shadow. There were no landers on that part of the far side. There were no rovers. There were no orbiting cameras positioned to catch the flash. The Chinese lunar rover Yudu-2, which had been exploring the far side since 2019, was in a completely different region, hundreds of kilometers away, and could not be repositioned in time. The only spacecraft that even had a reasonable chance of imaging the site was NASA's Lunar Reconnaissance Orbiter, a satellite that has been quietly mapping the moon in extraordinary detail since 2009. And it would only be able to photograph the site later, after the fact, once its own orbit brought it over the region under favorable lighting conditions, which meant that when the impact happened, nobody in the world would witness it directly. It would occur, as so many things in the history of the solar system have occurred, in total silence, in total darkness, unseen by any human eye. And it was going to happen in a matter of days. Before we go to the impact itself, before we stand in imagination on the surface of the moon and watch the last seconds of a 7-year drift come to their conclusion, let me pause and ask you this. In your own life, has there ever been a moment where you thought you knew with confidence where a story was going, and then someone gently, quietly, showed you that you had misread the whole thing? A moment where the identity of a person or a situation you had felt certain about turned out to be something entirely different? Tell me in the comments. Because this whole section is really about the humbling experience of thinking you have the answer, holding on to it for 7 years, and then being shown, in a single email from a stranger, that the picture is far more complicated than you thought. Now let us go to the 4th of March, to the moment the drift ends, to the moment 4 tons of metal from a rocket no one wants to claim meets a piece of the moon that has been undisturbed for 4 billion years. To understand what happened in the final seconds before the impact, you have to slow down. Slow down until you can almost feel time stretching. Because what is about to occur on that quiet Friday in early March is going to happen very, very quickly, and if we do not walk through it carefully, you will miss what makes it so strange. It is the 4th of March, 2022. The time is approaching 12:25 in the afternoon Greenwich Mean Time. On Earth, it is a Friday like any other. In London, offices are winding down for the day. In New York, people are drinking their morning coffee. In Beijing, it is late evening, and the streets are lit with the soft neon of a Friday night. Nobody in any of those cities is looking up. There is no reason to. The moon, at this moment, is not even in the sky for most of the world. And even for those who can see it, the impact is going to happen on the side we cannot see. There will be no flash. There will be no light. There will be no sound. Only somewhere beyond the horizon of our familiar moon, on a face we have never watched with our own eyes, a piece of metal will meet a piece of stone at 9,300 kilometers per hour, and something will change forever. Let us go there, not to Earth. Not to the control rooms and the offices and the quiet Friday afternoons. Let us go to the surface itself. Let us stand, in our imagination, inside a crater called Hertzsprung, on the far side of the moon in the last minute before impact. The place is silent. It has always been silent. Not the kind of silence you find in a quiet room, which is really only a partial silence, a silence full of your own breathing and the hum of distant traffic and the small clicks of a house settling. This is total silence, absolute silence. The kind of silence that exists only in a vacuum. There is no air. There is no wind. There has been no wind here for 4 billion years. The floor of the crater is a soft, powdery gray made of a substance called regolith, a fine, dust-like material formed by billions of years of tiny meteorite impacts, endlessly grinding the surface into a texture like flour. Beneath your feet, if you were standing here, that dust would compress very slightly with a strange, dry crunch. And then it would settle, and it would settle exactly, because there is no breeze to lift it, no water to move it, no life of any kind to disturb it. The footprint you left would still be there in 10,000 years. In 10 million, above you there is no sky, not really. There is only blackness, so deep and so total that the stars in it look almost hard, almost sharp, as though they were pressed into the darkness with a needle. The sun, if it were in your local sky, would be brutally bright, a burning white disk casting shadows so severe that the boundary between light and dark on the ground would look like a knife edge. But at this moment, on the 4th of March in the year 2022, the sun is not yet up over the horizon of Hertzsprung crater. It is lunar early morning. The impact site is in shadow. The temperature at ground level is somewhere around 170 degrees below zero on the Celsius scale. Cold enough that the metal of any spacecraft touching the ground would become brittle and behave in strange, unfamiliar ways. Now lift your gaze, not to the horizon, but higher. Because somewhere above you, moving in from a very specific angle, there is a small, tumbling shape. You would not see it with the naked eye. Not yet. It is still tens of kilometers up. It is still moving through the last stretch of empty space above the crater floor. But it is coming, and it has been coming for 7 years and 4 months. It is a hollow cylinder of aluminum, roughly 12 meters long, roughly 3 meters across at its widest. Its outer surface is scarred and weathered by 7 years of exposure to raw sunlight and hard vacuum. Its paint, if it ever had any, has faded and flaked. Its engines at one end are cold and dead. Its tanks, once full of liquid oxygen and kerosene, are empty. It has been tumbling since the day it was released, turning slowly end over end in the deep quiet of cislunar space, and it is tumbling still. It weighs about 4 tons. And it is moving in the last seconds of its long, patient drift at almost exactly 2.58 kilometers per second, which is to say, roughly 9,290 kilometers per hour. Let that number sit with you. 9,290 kilometers per hour. On Earth, a commercial airliner cruises at about 900 kilometers per hour. This piece of metal is moving more than 10 times faster than that. A high-powered rifle bullet leaves its barrel at somewhere around 4,000 kilometers per hour. This piece of metal is moving more than twice as fast as that. A meteor entering Earth's atmosphere from beyond the Moon typically arrives at speeds many times faster still. But for a piece of hardware that started its life on a launch pad in China, and that has been drifting for years without any propulsion of its own, 9,290 kilometers per hour is fast. Very fast. Fast enough that if you tried to imagine the last second of its flight in real time, you would not be able to. In the final second before impact, this object travels roughly 2.5 kilometers. In the final tenth of a second, it travels about 250 meters. In the final hundredth of a second, 25 meters. Faster than you can think. Faster than you can flinch. And it is about to meet the ground. At 12:25 and 39 seconds Greenwich Mean Time, or thereabouts, the impact occurs. There is no explosion in the way we normally use that word. There is no fireball because there is no oxygen for anything to burn. There is no thunderclap because there is no air to carry sound. What happens instead is something more silent and stranger and, in its own way, more violent. The tumbling cylinder strikes the regolith at almost 90 times the speed of a car on a motorway. The metal, in that instant, does not so much crumple as vaporize. The kinetic energy of 4 tons of hardware moving at 9,000 kilometers per hour is enormous. It is roughly equivalent to the energy released by detonating well over a ton of high explosive. All of that energy has to go somewhere, and in the vacuum of the Moon, with no atmosphere to absorb any of it, almost all of it goes into the ground and into the object itself. The ground answers instantly. A brilliant, silent flash of vaporized rock and metal erupts upward. Regolith, that fine gray dust that has been undisturbed for millions of years, is launched into ballistic arcs. Because there is no air to slow it, that dust travels in perfect geometric parabolas, some of it rising kilometers above the surface before falling gently back down. Fragments of aluminum, now heated to temperatures at which they briefly glow, spray outward in a bright, expanding cone. And beneath the impact point, the lunar surface itself is punched inward, compressed, then rebounded into a fresh, roughly circular depression. A new crater, a wound in a face that has been carrying such wounds for 4.5 billion years. The whole event, from the first touch of metal on dust to the settling of the last ejected fragment, takes perhaps a few seconds, maybe a little longer. And then, once the dust has fallen back to the ground, the crater sits there in the dark, still cold, still silent, indistinguishable in its immediate aftermath from any of the countless other craters that have been formed on the moon by random rocks over the last several billion years. The only difference is that this one was not caused by a rock. This one was caused by us. Nobody sees it happen. Nobody hears it. Nobody, in that moment, even knows precisely where on the far side it occurred, because the prediction had an uncertainty of some kilometers. Somewhere in Maine, Bill Gray checks his watch and knows that, if his calculations are correct, it has already happened. Somewhere in California, John Giorgini at JPL notes the same. In China, the government continues to say that its rocket is not there. In the offices of SpaceX, no one comments because it is no longer, in anyone's serious opinion, a SpaceX rocket. The world moves on with its Friday. It is a strangely quiet historical moment. The first accidental strike of a human-made object on another world, and nobody witnesses it. But the moon remembers. The moon always remembers, and this is where the story becomes truly strange. Because weeks later, in June of 2022, NASA's Lunar Reconnaissance Orbiter, that quiet, patient satellite that has been mapping the moon in fine detail since 2009, finally passed over the impact site with the right lighting conditions to see clearly what had happened. Its cameras took photographs. Its team of scientists compared those photographs to earlier images of the same area, taken years before, when the ground was still undisturbed. And when they laid the two images side by side, they saw the fresh crater exactly where Gray's calculations had said it would be. In the northern part of Hertzsprung on the far side, in a place no human eye had ever directly seen. But they did not see one crater, they saw two. Let that sit for a moment. They saw two craters, side by side, overlapping, their rims touching in the middle. One roughly 18 meters across, the other roughly 16 meters across. Together they formed a shape a bit like a figure 8 or a small peanut punched into the lunar dust. And that shape did not make sense. Because a normal impact from a normal object produces a single, roughly circular crater. It does not matter if the object is tumbling. It does not matter if it is hollow. It does not matter if it is elongated or irregular. At the speeds involved in a lunar impact, the object is so much softer than the ground compared to the kinetic energy involved that it essentially vaporizes on contact, delivering its energy in a single, focused pulse. The resulting crater is round. It has always been round. Every crater on the moon, formed by every kind of meteoroid over the last 4 billion years, is essentially round. A double crater from a single object hitting at nearly 9,000 kilometers per hour is not what physics predicts. It is not what any known spent rocket stage should produce, unless the object was carrying at each of its two ends a heavy, concentrated mass, something at the top, something at the bottom. Two dense weights, spaced apart along the length of the cylinder, each capable of digging its own crater into the ground before the rest of the object vaporized around them. A rocket upper stage does not normally have that. It has engines at the bottom which are dense and heavy, but at the top, it has only the empty ring where the payload used to sit, a light, hollow structure, not a mass. Whatever hit Hertzsprung that day was not a normal spent upper stage. It was something with weight on both ends, something with a payload it should not have had, or with additional hardware that no publicly documented mission has ever explained. The scientists at NASA who studied the images were careful with their language. They noted the double crater. They noted that it was unprecedented. They noted that it suggested the object had substantial masses at both ends. They did not accuse anyone of anything. They did not speculate publicly about what the second mass might have been. But among orbital analysts, among the small community of people who follow this kind of thing closely, a quiet question began to form. If this was the Chang'e 5T1 upper stage, and if it hit the moon with heavy masses at both ends, what were those masses? What had been attached to that rocket that we did not know about? Some possibilities are innocuous. It has been suggested, for example, that a piece of instrumentation, perhaps a test payload, could have been mounted at the top of the stage. Some possibilities are more speculative. Whatever the truth, the double crater is real. It is photographed. It is measured. And it remains to this day one of the strangest features of any known impact on the moon. There is a temptation, when you first hear this, to reach for something dramatic, to imagine secret hardware, hidden payloads, the geopolitics of space. But the honest, careful answer, the answer that the astronomers themselves offer, is that we do not know. We do not know what caused the double crater. We do not know, with absolute certainty, that the object was the Chinese Long March 3C upper stage. We are extremely confident of both, but the physical evidence sitting there on the far side of the moon is a shape that no one had predicted and that no one has fully explained. It is a small mystery, but it is a real one. And it is going to sit there in the lunar dust for as long as the moon exists, because here is the thing about lunar craters. They do not fade. They do not erode in the way that Earth craters erode. There is no rain. There is no wind. There are no rivers, no forests, no shifting continents, no ice ages, no oceans to reshape the land. There is only the very slow, very patient bombardment of tiny meteoroids, which will, over the course of tens or hundreds of millions of years, blur and soften the edges of any crater. But blur is not erase. That double scar punched into the ground on the 4th of March 2022 will still be visible if anyone or anything is around to look 100 million years from now. It will still be visible 1 billion years from now in a smoothed and softened form. It will outlast every city on Earth. It will outlast, in all likelihood, every language now spoken on this planet. It will outlast us and our children and our children's children into a future so distant we cannot really name it. We built a rocket. We launched it. We forgot about it. And in forgetting about it, we left a mark on another world that will still be there when the last trace of the country that launched the rocket has been erased from history. Let that sit for a moment. Let that be the weight of what happened on the 4th of March. Because it is easy, when you read about space debris and cislunar traffic and abandoned upper stages, to think of these as small technical matters, bureaucratic, regulatory, concerns for engineers and lawyers. But they are not only that, they are also this: a double crater on the far side of the moon that will outlast civilizations, a fresh scar on an ancient face made by our carelessness in a place we cannot see and did not intend to touch. And this, remember, is one object, one tumbling stage, one drift ending in one impact. There are others out there, right now, still drifting. Before we widen the view, before we look at how many more of these ghosts are quietly circling in the space above our heads, let me ask you something. And I mean this genuinely. Sit with the image of that double crater for a moment. Two overlapping circles of fresh dust, punched into a floor that had been undisturbed for hundreds of millions of years, in a place no human being has ever seen with their own eyes. And ask yourself this: does it feel to you like something small? A small technical curiosity, a footnote in the history of spaceflight? Or does it feel like something larger, something that stirs a quiet unease, the way it does in me when I picture it? I want to know how it lands for you. Because I think the answer says something about how each of us really feels about the age we are quietly, without ceremony, entering. Tell me in the comments. I would love to know. Now let us pull back. Let us rise up from the crater floor. Let us look at the wider picture. Because as strange as that one impact was, it is the very first drop of something much larger, gathering slowly above our heads. Rise now. Rise slowly in your imagination up from the floor of Hertzsprung crater, up from the fresh double scar in the dust, up above the gray and cratered landscape of the lunar far side. Let the ground fall away beneath you. Let the whole crater, 600 kilometers wide, shrink to a smudge, then to a spot, then to a texture on the pale, curving face of the moon itself. Let the moon become a sphere hanging in space, luminous on one side, dark on the other. And now let it become smaller still, a bright coin suspended in the black as you keep rising, as you keep pulling back, until you can see, in the same field of view, both the moon and the small blue and white world where you were born. This is the space we are going to look at now, the space between those two bodies, the corridor, the empty stretch of vacuum that until very recently, in the great sweep of history, was as clean and untouched as the ocean was before we built our first ship. Empty in a way that mattered. Empty in a way we did not appreciate because we had never known it any other way. That emptiness is ending. We tend to think of space debris, when we think of it at all, as a problem that lives just above our heads. And in low Earth orbit, that picture is roughly correct. Within a few hundred to a few thousand kilometers of the Earth's surface, in the region where the International Space Station orbits, and where most communications and observation satellites live. There is now a genuine, well-documented cloud of human-made objects circling our planet at extraordinary speed. It is a cloud that has grown since the very first satellite was launched in 1957, from a single object into something almost unrecognizable in its scale. As of the mid-2020s, the various tracking agencies around the world are following, at any given moment, tens of thousands of individual pieces of debris large enough to be catalogued, larger than about 10 centimeters across, fragments of exploded rocket bodies, dead satellites, panels torn loose in collisions, bolts, frozen droplets of leaked coolant, objects large and small, all of them moving at orbital speeds of roughly 28,000 kilometers per hour, all of them capable of destroying anything they hit. Beyond those tens of thousands of catalogued objects, there are hundreds of thousands more that are too small to track individually but big enough to be lethal to a spacecraft. Fragments the size of a marble, chips of paint, metal shavings. A dust cloud, essentially, moving at speeds where a single grain the size of a peppercorn carries the destructive energy of a bullet. And beyond even those, there are millions of smaller particles still, all of it building up, all of it accumulating. All of it, in some sense, the discarded exhaust of 6.5 decades of increasingly ambitious human activity above the atmosphere. That is low Earth orbit. That is the layer of sky closest to us, the layer we know best, the layer we at least try to monitor. But that is not the layer that the object which struck the moon was drifting through. That object was somewhere else, somewhere much larger, somewhere emptier, or at least emptier for now, somewhere that, until very recently, we barely tracked at all. That somewhere is called cislunar space. It is the vast, mostly empty volume of vacuum that stretches from just beyond low Earth orbit all the way out to the moon and slightly beyond. It is, in terms of pure volume, staggeringly larger than all the space in which our satellites usually live. If low Earth orbit is like a thin shell wrapped closely around the planet, cislunar space is like an enormous, three-dimensional room, roughly 400,000 kilometers across in every direction. To give you some sense of the scale, if you imagine shrinking the Earth down to the size of a basketball and putting it on the floor of a gymnasium, the region of low Earth orbit would be a very thin skin of activity clinging to the surface of that ball. The moon, on the same scale, would be a tennis ball on a shelf across the room, about 7.5 meters away. And cislunar space would be everything between the basketball and the tennis ball. All of that emptiness, all of that quiet volume of vacuum. That is where objects like WE 913A drift. That is where the abandoned upper stages of missions to distant destinations end up. That is the space that, for most of the space age, has been treated as an ocean too large to bother mapping. For decades, that treatment was more or less defensible. There were only a few dozen human-made objects in cislunar space at any given time, most of them long-defunct spacecraft or discarded rocket stages from missions that had ended years or decades earlier. Radar systems on Earth could not easily see that far. Optical telescopes had trouble picking out small, dim objects against the darkness beyond low Earth orbit. And most importantly, there was no real economic or scientific reason to care. Nobody was flying regular missions through cislunar space. Nobody had a permanent installation there. If a piece of debris drifted through, it would almost certainly not hit anything. The corridor was, in effect, so wide and so empty that even the growing population of ghosts within it did not pose any obvious threat. That era is ending. Because in the decade you are living in right now, in the mid-2020s, humanity is beginning, quietly and rapidly, to fill cislunar space with activity. NASA's Artemis program, an ambitious effort to return astronauts to the surface of the Moon and eventually to establish a sustained presence there, is underway. China is planning its own crewed lunar landings, along with a research station near the lunar South Pole. India, having successfully landed its Chandrayaan-3 rover near that same pole in 2023, is planning follow-up missions and, eventually, its own astronauts. Japan, South Korea, and the United Arab Emirates have all launched lunar spacecraft. Private companies, some funded by NASA and some pursuing purely commercial interests, are sending small robotic landers to the surface. Communications satellites are being placed in lunar orbit. A space station, called Gateway, is planned to orbit the Moon in the coming years, forming a staging point for missions to the surface and, eventually, to Mars. All of this activity means that cislunar space is no longer the quiet, empty corridor it once was. Traffic is beginning to build, and where there is traffic, there is, sooner or later, debris. Consider what this means. Consider that in the space of just a few years, the corridor between the Earth and the Moon is going to go from being crossed by roughly one mission a year to being crossed by dozens. Each mission involves rockets, and every rocket has stages. Some of those stages will be recovered. Some will be disposed of properly, either by re-entering Earth's atmosphere or by being pushed into safe, distant orbits around the Sun. But some, inevitably, will not. Some will be left, like the Chang'e 5T1 stage was left, to drift on whatever trajectory they happen to be on when their engines shut down for the final time. Some will be lost. Some will fail during their disposal maneuvers. Some will collide with each other or with natural micrometeoroids and break into smaller pieces. And every one of those pieces will join the slowly growing population of ghosts now inhabiting the space between our world and the Moon. There is a name for what happens when this process runs too far. It is called Kessler syndrome, after the American scientist Donald Kessler, who described it in a paper published in 1978. The idea is simple and quietly terrifying. In any orbital region, if the density of debris rises high enough, collisions between objects become frequent enough that each collision produces more debris than it destroys. That debris then causes more collisions, which produce more debris, which cause more collisions. In the worst case, the process becomes self-sustaining. A runaway cascade. A cloud of high-velocity fragments growing on its own without any further human contribution, until the region becomes essentially unusable for spaceflight for generations. Not because any single object is catastrophic, but because the aggregate cloud makes safe passage impossible. Kessler syndrome has been discussed for decades in the context of low Earth orbit, where the density of objects is highest and the risk is most immediate. It has not, historically, been a concern for cislunar space, because the volume of that space is so enormous that even a growing debris population is spread very thin. But the physics is not qualitatively different. The physics just requires more objects. And we are now quite deliberately adding more objects, not maliciously, not carelessly, but steadily, mission by mission, launch by launch, year by year. The corridor is filling, slowly but genuinely. And there is a further complication that makes cislunar debris harder to manage than debris in low Earth orbit. In low orbit, there is a natural cleansing process. The very thin outer layers of Earth's atmosphere reach a bit further out than most people realize, and they exert a small but persistent drag on anything orbiting through them. Over years or decades, that drag slows a piece of debris down. Its orbit lowers. Eventually, it re-enters the denser air below and burns up. Low Earth orbit, in the long run, cleans itself. Not fast enough to keep up with what we are putting there, perhaps, but it does clean itself. Cislunar space does not. There is no atmosphere in the corridor between the Earth and the Moon, nothing at all to slow a piece of debris down. Once an object is drifting in cislunar space, it will continue to drift, essentially forever, until it either strikes something or is deliberately removed, which at present is almost never possible. Think about that. Every ghost we place in cislunar space is, for practical purposes, permanent. Every abandoned upper stage, every discarded shroud, every dead lander that misses its target and skips back off the lunar surface into space, all of them, once they are there for good, not for a lifetime, not for a century, for as long as anyone can plan for. They will still be drifting in some slowly shifting orbit when your grandchildren are old. They will still be drifting when the last person who remembers the 21st century has passed away. And this is where the fresh double crater in Hertzsprung stops looking like a curious accident and starts looking like a preview. Because if one abandoned upper stage over the course of 7 years could drift into the Moon by accident, then more will. It is essentially guaranteed. As the number of forgotten objects in cislunar space grows, the odds that one of them, on some chaotic trajectory, will eventually intersect with the lunar surface grow with it. The Moon is, by cosmic standards, a very large target. And it happens, coincidentally, to be located at the edge of the very region where we are quietly accumulating ghosts. Some of those ghosts, over years and decades, are going to find their way into it. Not all at once, not in a shower, but steadily, quietly. One at a time. We are entering, whether or not we are ready to admit it, the era of routine human-made craters on the Moon. Some of those craters will be intentional. Missions have deliberately crashed hardware into the lunar surface many times. Going all the way back to the Soviet Luna 2 in 1959, and there are good scientific reasons to do so. For instance, to kick up plumes that can be analyzed for water content or to conduct seismic experiments. But some of them, going forward, will not be intentional. They will be like the double crater in Hertzsprung, accidental, unnoticed at the time, discovered weeks or months later when a passing spacecraft happens to photograph the ground and finds a fresh mark that was not there before. Some of them may never be discovered at all. There is a great deal of lunar surface, and only a small fraction of it is regularly imaged in high enough resolution to detect a fresh crater the size of a house. There are, right now, almost certainly features on the far side of the moon that no camera has ever resolved in detail. If a small piece of debris hit any of them tomorrow, we might not know for years. We might never know. And it is not only the moon. Consider the same logic applied to the growing traffic further out. To Mars, where every mission that arrives brings with it hardware that will remain on or around the planet forever, whether or not the mission itself succeeds. Consider the asteroid belt, where robotic probes now visit regularly, and where the first tentative discussions of resource extraction are already underway. Consider the outer solar system, where deep space probes have been sent for decades, and where their spent boosters and adapter rings are already drifting, in some cases, on trajectories that will eventually, over millions of years, take them past other bodies. Every place we go, we leave things. Every mission is a small deposit, and the physics of empty space is such that those deposits, unlike our deposits on Earth, do not decay. They persist, they accumulate, they wait. There is a phrase that some astronomers have started using quietly in the last few years to describe this new phase of human activity in space. They call it the beginning of the Anthropocene of the solar system. On Earth, the term Anthropocene refers to the current geological epoch in which human activity has become the dominant force shaping the planet's surface, climate, and ecosystems. The suggestion is that we have now entered a similar phase on a vastly larger stage. That the solar system itself is starting to bear our fingerprint. That the surfaces of other worlds, the corridors of space between them, are beginning to record our presence in ways that will persist for geological and even astronomical timescales. The double crater in Hertzsprung is one such fingerprint. It is not the first. There are older ones on the near side of the moon, left by Apollo hardware and Soviet probes, and more recently by deliberate impact experiments. There are wheel tracks on Mars, left by rovers. There is the wreckage of a small Israeli lander that crashed into the lunar surface in 2019, carrying, among other things, samples of DNA and a colony of microscopic creatures called tardigrades whose fate remains a subject of ongoing debate. There is the discarded hardware of dozens of Soviet and American moon missions from the 20th century, scattered in various states of preservation across the near side. There is perhaps most poignantly a small plaque left on the moon by the Apollo 15 astronauts in 1971. A small metal figure of a fallen astronaut laid gently on the dust in memory of the men and women, American and Soviet, who had died in the effort to reach space. All of them are still there. All of them will still be there in 1,000,000 years. All of them are, in some real sense, part of the moon now, part of its story. But the Hertz-sprung double crater is different from all of these in one important way. It is the first of its kind. It is the first known unintentional impact of a human-made object on another world. It is the first mark on another surface that we did not choose to leave. It is, if you like, the first accident of the extraterrestrial Anthropocene. And accidents, once they begin, tend to keep happening. The question is not whether there will be more. The question is only how many, and when, and in how many different places. There is something both humbling and quietly disturbing about that thought. Humbling because it forces you to see that we are, in fact, a significant presence in the solar system now. Not everywhere, not densely, not in the way we are on Earth, but significantly, enough to leave marks that will persist for cosmological timescales. Enough to alter, however slightly, the surfaces of worlds that were, until very recently, entirely beyond our reach. And disturbing because it forces you to see that we have already crossed a threshold that we did not really discuss beforehand, that we did not vote on, that we did not, as a species, sit down and decide. The threshold was crossed by accident, by a piece of a rocket drifting for 7 years, arriving at a place it was never designed to reach, striking a piece of ground that had been undisturbed since long before the first human being was born, and no one on Earth was watching. Before we begin our final descent, before we move into the closing thoughts of tonight's exploration, let me ask you something one more time, because this section has been, in some ways, the hardest to sit with. It is one thing to hear about a single impact, and to feel a small, curious wonder about it. It is another to zoom out and see that the impact was not really singular at all, that it was the leading edge of something much larger, something we are only beginning to notice. So here is my question. When you look up at the moon now, tonight, tomorrow night, next week, knowing what you now know, does it look the same as it used to? Or has something quietly shifted? Tell me honestly in the comments. Because I think many of us are learning slowly that the sky above us is not what we were told it was as children. And I think that shift, small as it may seem, is worth naming. Now let us gather what we have seen. Let us bring the whole story home. Let us close. Let us come back for a moment to where we started, to the pristine silver moon of your childhood, hanging in the sky above your bedroom window, quiet and distant and untouched. That image is not gone. It is still there in some corner of your mind, and it always will be. But it has been joined tonight by another image. 2 overlapping circles of fresh dust, punched into an ancient crater floor on the far side, made by a rocket that no country wanted to claim, arriving in silence and shadow while the rest of us went about our Friday afternoons. That, too, is now part of the moon. That, too, is now part of what the word moon means to you. We have come a long way tonight. We began with a launch. A tall white rocket rising over Florida on a February evening in 2015, carrying a small satellite toward a balance point in the sunlight, 1.5 million kilometers from Earth. We watched the upper stage of that rocket be released into a distant orbit, quietly forgotten in the celebration of a successful mission. We followed for years, a small drifting shape through the empty space between the Earth and the Moon, a tumbling ghost that no one was watching until, one January evening in 2022, a retired programmer in Maine noticed the numbers on his screen had changed. We followed him back through his own calculations, through the polite email from a stranger at JPL, through the re-identification that turned an American rocket into a Chinese one, and through the denial that turned a straightforward accident into a small international mystery. We stood in imagination on the floor of Hertzsprung crater on the 4th of March 2022 and watched a piece of metal we could barely have imagined arrive at 9,000 kilometers per hour, in absolute silence, into a place no human eye had ever seen. And we saw, in the images that came back weeks later, that the impact had left not one crater but two, a small, quiet mystery that no one has fully explained even now. Then we rose, and we widened the view, and we saw that this one event was not really singular at all. It was the very first drop of something larger. The first accidental scar in a growing pattern of human presence across the solar system, the first quiet fingerprint of what some astronomers are already calling the Anthropocene of the sky. That is the journey. And now, at the end of it, I want to try to say something honest about what all of it might mean. Because here is a strange thing. All night, we have been asking a question that seems on its surface to be quite specific. Whose rocket hit the moon? Was it American? Was it Chinese? Was it a piece of forgotten hardware from 2014 or 2015 or something else entirely? Who was responsible for the double crater in Hertzsprung? Whose ghost was that? And that question, as we followed it, kept becoming harder to answer. Every time we thought we had the identity fixed, the picture shifted. Every time we thought we knew whose fault it was, the fault turned out to belong somewhere else, or nowhere in particular, or to a system rather than a person. And by the end, we found ourselves looking at a question that has, in a certain sense, dissolved. Because the truthful answer is not really the name of a country, or a company, or a mission. The truthful answer is that a piece of us, of humanity as a whole, arrived at a place we had not intended it to go, and left a mark that will outlast every institution now living. The question of which flag was on the side of the rocket has become, by the end of the night, almost beside the point. What matters, what actually matters, is that the mark is there, that we are now a species that leaves marks on other worlds, that we have been for some time without quite noticing it, without quite consenting to it, without quite deciding it, and that it is only going to become more true from here. There is a way of hearing that fact that leads to despair. A way that says, look, we have already begun to litter the sky. We have already begun to leave our mess on the surfaces of other worlds. We could not even keep our own atmosphere clean, and now we are starting on the vacuum between the planets. What hope is there for us? What kind of species does this? What does it say about us that our first fingerprint on another world was left by accident, by an object that nobody claimed, that no one was watching, that no one had planned for? I understand that reading. But I do not think it is the only one. And I do not think, sitting here tonight at the end of this long story, that it is the most honest one. Because there is another way to hold what we have learned. A way that begins with a simple recognition. The moon has been struck for 4.5 billion years. Every crater on that ancient face is a story of arrival. Every scar is a record of something reaching the surface from somewhere else. The moon has never been untouched. It has never been pristine. It has been from the very first moment of its existence a receiver, a patient, silent recorder of visits, of collisions, of arrivals from the dark, rocks from the asteroid belt, fragments of comets from the outer solar system. Micrometeoroids by the trillion, quietly sanding down its surface for eons. The moon has always been in a slow, gentle conversation with the rest of the solar system, one impact at a time, and it has always been changed by what has touched it. What we did on the 4th of March 2022 was join that conversation, not gracefully, not intentionally, not with any particular dignity, but we joined it. For the first time in the 4.5 billion year history of that pale gray world, something arrived at the surface not from the random, indifferent turning of gravity in a solar system full of drifting rocks, but from a place with intention. From a place with rockets and dreams and mistakes, from us. And whatever else you want to say about that, whatever else you want to feel about it, it is not nothing. It is, in a certain quiet way, a kind of arrival. The first, clumsy, unwitnessed arrival of a species that is only beginning to learn what it means to be present in a place larger than its own home. There is a temptation, when we tell stories like this, to look for the villain, to point at the rocket, or the country that made it, or the company that abandoned it, or the international body that failed to regulate it, and to say, there, that is what went wrong, that is who is to blame. And in a technical sense, we should. We should have better systems for tracking upper stages. We should have clearer rules for disposal. We should have international agreements about who is responsible for what, once a rocket has crossed a certain distance from Earth. All of that is true. All of that will, in time, be built. Because these problems have solutions, and human beings, given enough time, are actually reasonably good at solving problems of exactly this shape. Slowly, imperfectly, and often only after an accident forces the issue. But we do get there in the end. And the double crater in Hertzsprung is, in a way, the first small accident that begins to force that conversation. It is the first sign, written on the ground of another world, that we can no longer treat the vacuum above us as a place where things do not matter. It is the first proof, punched into the lunar dust, that things there do matter, that the choices we make about our upper stages, our mission profiles, our disposal orbits, are real choices with real consequences, that they will show up somewhere, sometimes on our own world, sometimes on someone else's. And the fact that this proof has now appeared on the far side of the moon, on a face we cannot see, on ground we cannot easily reach, does not make it less real. It makes it more so. Because the moon does not care about your headlines. The moon does not care about press releases or denials or corrections. The moon simply records. Everything that touches it, it keeps. And what it has kept since the 4th of March 2022 is a small, precise record of something we did without meaning to. A record we cannot erase. A record we cannot walk back. A record that will still be there when every voice in this conversation, mine and yours and everyone we love, has long since fallen silent. Let me address you directly for a moment as the person you are, listening to this. You are statistically most likely alone right now. Perhaps in bed, perhaps in the dark, perhaps with your eyes closed. You have carried an image of the moon in one form or another for as long as you can remember. You looked at it as a child from a car window on a long drive. You looked at it perhaps from a beach in the summer. You looked at it perhaps on a night when something in your life had gone wrong, and you needed to remember that there was something old and steady in the sky, something that had been there before you were born and would be there after you were gone. That moon is still in the sky. It has not changed. The scar on its far side does not touch, in any meaningful physical way, the face you have known your whole life. Nothing about your relationship with it has been broken. Nothing about its steadiness has been diminished. But something, quietly, has been added. You now know something you did not know before. You know that there is a piece of us up there, that the sky above you contains not only the ancient moon and the ancient stars, but a small, growing archive of our own presence. That when you look up on a clear night, you are not only looking at the deep past, you are also, in a very small way, looking at us, at what we have done, at what we are doing, at what we will keep doing more and more as the century goes on. That is not, I think, a sad thing. Or if it is sad in the way that all real growth is sad, in the way that a child leaving home is sad, in the way that the end of a familiar era is sad, even when the era that follows is more open and more possible than the one before. We are, whether we chose it or not, becoming a species that leaves marks on other worlds. And that fact carries with it a responsibility that we are only just beginning to learn how to hold, to be careful, to be intentional, to be, in the fullest sense of the word, awake to what we are doing. The double crater in Hertzsprung is, in a way, our first lesson in that awakening, written in dust, on a face we cannot see, in a place we did not choose. And it will be there, patient and silent, for as long as we care to remember what it was for. Before I let you go tonight, one small, honest request. If any of this has stayed with you, if you feel the moon looks even slightly different than it did an hour and a half ago, if you feel some small, quiet unease or wonder or awe at where we have traveled together, then a like on this video, a subscribe, if you have not already, means more than I can easily say. It is not, for me, a matter of algorithms and numbers. It is a matter of knowing that these long, slow explorations, these nights of walking together through a story from beginning to end, matter to someone. That there is a small community of us who like to sit with the sky this way. It costs you nothing. It means everything. Thank you sincerely for having been here. And now, gently, we come to the end. The rocket that struck the moon on the 4th of March 2022 is still there. It is not, of course, a rocket anymore. It is a vaporized mist of aluminum settled across a small patch of lunar dust, and two overlapping craters that will slowly, over millions of years, be smoothed by nothing more than the endless, patient rain of tiny meteoroids. It is a mark, a small, permanent mark, on a world that has been carrying marks for 4.5 billion years. It has joined the story of the moon now. It is part of that story. It will still be part of that story when the last human being who ever lived has been forgotten, when our cities are dust, when our languages are gone, when even the shape of our continents has shifted into something no one alive today would recognize. The double crater will still be there, on the far side in the ancient bowl of Hertzsprung, quiet under a sun that will still be shining, in a sky that will still be black. And someone or something may one day stand there and look at it, may kneel down and touch the edge of the wound, may trace, with a hand or an instrument or a sense we cannot even imagine, the shape of what we left, and they may wonder about us. They may wonder who we were, what we wanted, what we thought we were doing when we set that rocket on its journey. They may wonder whether we ever understood in our brief and busy time the strangeness of being the first species on our world to reach the surface of another. They may forgive us for how carelessly we did it, or they may not. It is not really our concern. Our concern is only what we do next, what we do now in the years we still have, in the age we have quietly begun. For tonight, though, that is enough. Enough thought, enough distance, enough of the immensity above. Close your eyes if they are not already closed. Let the image of that quiet crater rest for a moment in your mind and then let it go. Let the moon return in your inner sky to what it has always been, not pristine, not untouched, not distant, but familiar, present. A companion hanging in the black above your bedroom window exactly as it has hung for 4.5 billion years. Older than every worry you have ever had, older than every fear, steady, patient, yours. Rest now, rest deeply, rest well, sleep well under the stars. Good night.